Okay, so we're going to get into now how to divide these polynomials. So far we've talked about adding and subtracting and multiplying them, and then we went into like expanding them using Pascal's triangle. So after multiplication is naturally division. And what we're going to talk about first, we actually have two ways to divide polynomials. The first way is using long division. So I want to just kind of go over how did you do long division when it was just a number. Okay, so you would have learned this a long time ago when you were first learning how to divide. You did long division first. So if we had something like 305 divided by 4, what we would do, remember, is kind of write this out with the 4 sitting out front, and the 305 goes underneath that division sign. So your thought process with long division is 4 trying to go into the numbers 3, 0, and 5. Since 4 can't go into 3, we then have to go into 30. So you look at the first two numbers. So 4 can go into 30 7 times, because 4 times 7 is 28. So you would put 7 up above, like right above the 0, and then you multiply. 7 times 4 is that 28, and you put that underneath the 30, and then you subtract. So 30 minus 28 is 2, and then we bring down the 5. So now we're trying to get 4 to go into your 25. How many times can 4 go into 25? 6 times. So the next number up here on top is going to be 6. 4 times 6 is 24, so we put 24 underneath the 25, and that's going to give you 1. Okay, so 1 is your remainder, because I'm out of numbers to drop down from up above. And so this is when we were dividing numbers, like if you had a calculator and you divided this, you're going to get a decimal. And so that's where that remainder comes from, is that's the decimal piece. So to write the remainder, you take that whole number piece up here, 76, and then we write the remainder like a fraction. So it's the 1, and we put it over what we were dividing by, which is 4. So this would be 76 and 1/4. Now, if you actually took 305 divided by 4 on a calculator, you would probably get 76.25. Okay, so if you wanted to check it, you could actually divide and make sure that we got the same answer there. But either way, 1/4, 0.25 are the same thing. They're talking about the same quantity there. So we're going to use this same method, the same steps, same process for dividing these polynomials now. So I'm going to show you how this looks and kind of do some examples with you guys. So we're going to take something like 4x to the second plus 3x to the third plus 10 divided by x minus 2. Now when you go to set this up as a division problem, make sure that the polynomial that goes underneath your division bar is written in standard form. So put the biggest exponent first, and then the next biggest, and then the next biggest, until you get down to the smallest number, or the smallest exponent. So the x minus 2 piece, that's what sits outside of the division bar. Under the division bar, then, I need to put this 4x squared plus 3x to the third plus 10. And I'm going to rewrite it so that it's in standard form. So the biggest exponent I see is x to the third. So 3x to the third is going to get written first. And then your 4x squared. And then your plus 10. Now, not all of them will always be written out of order like that. You will have some that already are in standard form and you don't have to do the rewriting, but just make sure that if you do have to rewrite, that you start there first. All right, so now we're going to get into how do we divide this, because it's a little bit different than just like taking a number into something. We're trying to take this whole quantity x minus 2 into these pieces. So you start with the x, and you look at the first term, which is 3x to the third. You ask yourself, x times what would get me to 3x to the third? So I'm missing a 3, so I'm going to have to multiply x by 3. And since I have 1x and I'm trying to get to 3x, like x to the third, I'm missing 2 of them. Think about when you add your exponents. I'm out of 3. Right now my exponent of x is 1, so I'm missing 2, so I need an x squared piece. So 3x squared times that x out front is how I get 3x to the third. So when you multiply with polynomials, you should always be able to get those first terms to match. Okay, so what you do next then is you take the 3x to the second, that piece that we wrote up on the top there in green, and we multiply that also by the negative 2. So 3x squared times this negative 2 out front is going to be negative 6x squared. And that's going to go right underneath the 4x squared. We subtract, just like we did up above on a regular long division. We always subtract it. And when this happens, those first two terms should always cancel each other out. So the 3x to the third minus 3x to the third is gone. Now 4x squared minus a negative 6x squared. Really be careful with your signs here, because this one you have double negatives. Remember, when you guys have minus a negative, that becomes an addition problem. So we're doing 4x squared plus 6x squared. And so that's going to be 10x squared. Okay, so now we're going to repeat the process. Our new term that we're trying to get to now is 10x squared. So I'm thinking about x times what is going to get me to 10x squared. Okay, and we can also drop down this 10, this plus 10. All right, so x times something to get me to 10x squared. Well, I'm missing a 10, so I'm going to have to do plus 10. And then x, to try to get it up to x squared, I need another x, because x times x is x squared. So up here, I'm going to take it times 10x. Now I repeat my process. So 10x times the x is going to be 10x squared. Again, the first term should match. That way, because when we subtract, we want to get rid of them. And now we take 10x times that negative 2, which is going to be negative 20x. So now look at our original polynomial. Do you guys see how the original one skipped over the x term? Like it went straight from 4x squared to plus 10. So when I go to subtract here, it might be helpful if instead of writing plus 10 right away, we think about where would that x term be. So I'm going to rewrite this just for a second for you guys. So right here in between the 4x squared and where I had that plus 10, I'm going to add in a 0x, just to kind of hold that place for you guys, and then have a plus 10. So instead of bringing down that plus 10 right away, I'm going to bring down the 0x so that it makes a little bit more sense when you guys are going to subtract. So I'm going to put a subtraction sign now out front, and then we do the same thing that we did before. So 10x squared minus 10x squared, those are gone. Now because my original polynomial doesn't have an x, it's like 0 minus negative 20. Again, we've got double negatives here, so that's going to come out to be positive 20, because it's 0 plus 20. So we have 20x. And now I'm going to bring down this 10. Okay, and then we repeat our process. So I'm trying to get to 20x, and I have my x up there. What do you guys think? X times what would get me to 20x? You're right with the 20, but I already have an x with it, don't I? So just 20, because if I did 20x, I would need 20x squared there. So x times 20, so I'm just going to write plus 20 here. I don't need the x because they both already have 1x. So x times that 20 is 20x. Then we take 20 times the negative 2. That's negative 40. and then once more we subtract. So 20x minus 20x, that's gone. Now we have 10 minus negative 40. Then you've got double negatives, 10 minus a negative, so that's 10. Change that keep, change rule. So 10 plus 40 is 50. So 50 is our remainder. Okay, so like before on that problem up above when I did just numbers in long division, remember how I wrote the remainder? I took that 1 that was down here at the bottom, and I put that over the 4 that we divided by. You're going to do the same thing for these polynomials. Instead of having just like a 1 and a 4 though, I've got 50, and the thing that I divided by was x minus 2, so it's like this quantity. So how I'm going to write my answer is I take the polynomial that I have up here, okay, 3x squared plus 10x plus 20. That stays the same. And then we just add on or subtract if it's negative that remainder. So my remainder is 50. So it's positive, so I'm going to do plus. Put 50 on top of my fraction for my remainder, and then I put it over what we were dividing by, which is the x minus 2. All right, we're going to do some more examples. That was probably the first time that maybe you've seen that, and it can be a little overwhelming the first time you see it, because there's a lot that you're trying to keep track of, and you're trying to figure out how to get those letters to match. So it does take a little bit of time to kind of figure out how these things flow, but the same process happens every single time. Like there's nothing different that I'm going to throw at you when it comes to these division problems. You're just constantly trying to figure out this quantity times what, and you got to just figure out what that what piece is to get something in that problem. Let's do another one here together. Let's look at the second one in your guys' notes there. This one we have 5x to the third plus 43x squared minus 45x minus 30 is trying to be divided by 5x minus 7. So look at that big polynomial. It's already written in order for us. It goes x to the third, x squared, x, and then a number. And it doesn't skip over anything. Like it doesn't skip over an x. So I won't have to put any like zeros in the place or like the whole places or anything like that. So let's go ahead and write this out. 5x minus 7 sits out front. And then underneath the division bar is going to go that 5x to the third plus 43x squared minus 45x minus 30. All right, so we have 5x out front, and we're trying to get to a 5x to the third. I don't need to do anything with the 5s. They both already have 5s. So let's talk about the letters. I have 5x, and I want to get to x to the third. So how many more x's, or what's my exponent that I need to multiply by to get from 1 to 3? What would you add to 1 to get to 3? 2. So you're going to multiply by x squared. You don't need to do 5x squared because it already has a 5. So we're going to do x squared here. So x squared, take it times the 5x out front. That's going to get me my 5x to the third. Now I also have to take x squared times the negative 7. So I already did it times the 5x. Now we'll take it times the negative 7. So x squared times negative 7 is going to be negative 7x squared. So that goes right underneath the 43x squared. Okay, are we good on how I got those two pieces? Yeah? Or do we have questions? Do you see how they already have 5s? so I don't need a 5, because otherwise I would be getting, if I took another 5, it would be 25. So all I need to do is think, I've only got x, I need to get to x to the third. So x times x squared would be x with a 1, x with a 2, so you add the exponents. So that's why I did x squared. So then after I get my x squared, I also take it times -7. So you know how we got -7x squared? You know where that came from? So now what we're going to do is subtract. So remember, I said when you subtract, those first two quantities should just always cancel out because they're the same thing. So 5x to the third, 5x to the third, those are gone. We've got 43x squared minus -7x squared. You got double negatives again, so you're going to have to add. So what would be 43 plus 7? 50. So we're going to have 50x squared. And then I'm going to go ahead and bring down that minus 45x. Okay, now we repeat our process. We come back up to the 5x minus 7. So 5x, I need to get 5x to become 50x squared. So let's start with the 5. How would we get 5 to 50? With multiplying. 5 times what would get you to 50? 10. So we're going to have a 10. And then x times what would give me x squared? X times x. So I need an x attached to my 10. So 5x times 10x is going to be that 50x squared. Then I also have to take the 10x times that -7. That's still from the division piece. So that's going to be -70x. Okay, and let's subtract again. So 50x squared minus 50x squared, again, those pieces should just eliminate. What is going to be -45 minus a -70? Or -45 plus 70? 25x. Yep, so this is going to be 25x. And then bring down that -30. Now we repeat, okay? Go back up to that 5x minus 7. I got to go from 5x to 25x. So how would I go 5 to 25? Times 5. Now they already both have x's, right? 5x, 25x, so I don't need an x. Okay, so now I also have to do -7 times 5, which would be what? 35. So I've got 25x minus 35. We subtract once more. So 25x minus 25x is gone. -30 minus -35, or -30 plus 35 is going to be what? 5. And that's my remainder. Okay, and I know that I'm done for a couple of reasons. I have no more pieces from my problem to drop down. I used that 30. That was my last arrow that I drew down. I've got no more things to draw down. They're all gone. Also, if you guys look up at your answer, see how it goes x squared, x, and then the 5? There's no more x terms, so there's nothing left. Once you get to a number, you're done. You're at the end of the polynomial. That's the smallest that you can get. So I know that I'm done. That means that this 5 here is my remainder. So up here on the answer, x squared plus 10x plus 5, we need to add in this remainder of 5 here. So since it's positive, we do plus. That 5 goes on top. What piece goes on the bottom? Good, what we divided by, the 5x minus 7. So this right up here is your answer. I'm boxing in purple right now. That's your final answer. So far we've seen examples where you have remainders. There will be some cases where you don't get a remainder, that everything kind of just works out perfectly. If that happens, you'll get a 0 here, like where I have my 5, you'll have a 0 show up. You don't have to write plus 0 divided by your divisor, because that's just going to be a 0. So if that happens, I would just leave it as the x squared plus 10x plus 5 and just box that up and call it good. Okay, so why don't you guys try this next one. Just do as much as you can and see what happens. All right, so how would we go from x to 4x squared? Good, times by 4x. So your first term up here should be 4x. Okay, so then 4x times that x is how we get 4x squared. And then we take 4x times the 1, and that's just going to be 4x. And we subtract. So the 4x squareds are gone. Now this one, there's no double negative here, so you go ahead and just subtract, because it's 5x minus 4x, which would leave you with what? X. So x, and then I'm going to bring down that plus 1. Okay, do you guys see how we've got x plus 1 there, and that's what we're dividing by? We're dividing x plus 1 by x plus 1. So that's the same thing as like if you were trying to take 5 divided by 5 or 10 divided by 10. You're going to get a 1 here. Because I already have x and I'm trying to get to an x. So I don't want to multiply by any more letters because otherwise I'm going to start getting x squareds. So I'm really only going to multiply by a 1. So that x times 1 is x. And 1 times 1 is 1. So when I subtract on this one, everything cancels out because x minus x is 0, 1 minus 1 is 0, so I get a remainder of 0. This is that case I was talking about that there is no remainder. So my answer is just 4x plus 1. Okay, there's one more in your guys' packet. And again, I'm going to give you guys a couple minutes for you to give it a try and see what you can figure out here. Okay, so how would we go from 9n to 9n to the third? What'd you say? N squared. Okay, I don't need a 9 because I already have 9s. I just need to get my n to an n to the third, so we take it times n squared. So 9n times n squared is 9n to the third. And then what else do I need to multiply n squared by? The 8. So that would give me 8n squared. And again, it's positive. So when I actually subtract, I'm going to subtract. I don't have to worry about double negatives here, because both of these terms are positive. So the 9n's to the thirds are gone. What's going to be 80n squared minus 8n squared? Good. 72n squared. And then we bring down the 109n plus 109n. Okay, so let's start over. 9n times what will get me to 72n squared? 8. And do you need any letters? You need one n, right? Okay, so 8n times 9n is 72n squared. What's 8n times 8? Good, so we have plus 64n, and then we subtract again. Okay, so 72n squared minus 72n squared, that's gone. What is 109 minus 64? Flip the numbers around. 45. So 45n. You were close. Drop down that 36. Okay, so 9n times what will get me to 45n? 5, just 5. I don't need any more n's. So plus 5. So 9n times 5 is 45n. And I also have to take 5 times 8, which is 40. Subtract one more time here. 45 minus 45n, those n's are gone. What's 36 minus 40? Positive or negative? So negative 4. And that's your remainder, because I don't have any other pieces left for me to drop down to try to divide one more time. And also, up in my answer so far, I'm ending with a 5. It doesn't have any letters, so there's nothing left for me to do. Now, for my remainder on this one, since it's negative 4, instead of writing plus, like I did on those last ones with remainders, I am going to write minus, because it's a negative number. And I'm going to put 4 on top of what goes on the bottom. Good, 9n plus 8. So this up here is your answer. All right.